My name's Greg Kuelgen, and I'm an architect with Apogee at Google Cloud.
Hi, I'm Dino Chiesa. I'm a colleague of Greg's on the Apogee team at Google Cloud.
So I'm very excited to be here today to talk to you about some means of securing your APIs. There are a couple key points we hope you take away from this session. 1. API security is not one size fits all. Depending on the purpose of the API, the audience, the data, etc., there will be varying techniques you may use to protect that API. While there are certainly some things we view as base requirements, for example, transport layer security, the approaches we talk about are designed to be layered and used where appropriate. 2. Security is not static. What works today may need to adapt tomorrow. 3. Tools like Apogee can help manage the security of your APIs. Dino and I frequently talk to customers about API security. Over the past few years, the number of attacks that we see and the number of conversations we have about security have been steadily increasing. Securing access. This is generally what I believe most of us think about when we think API security, making sure that we have authentication and authorization in place. As the slide states, the caller presents something, and the receiver checks to see if access should be granted. In basically all cases, you'll want to use TLS to secure the connection, also known as one-way TLS. So let's talk about a few means of actually securing your access. First, API key. I really think of an API key more as a way to identify a calling app than a true security mechanism, though it's often a building block for security mechanisms such as OAuth. OAuth is a very commonly used method of authentication and authorization. It has allowances to let a consumer authenticate their account and approve access for certain parts of their account. We've all gone through this authorization flow where you log into an account with an app, it redirects you to another login, such as your Google login, and then asks whether you grant the app permissions to access your data. In one-way TLS, which is another means of securing, the client identifies the server with the certificate presented by that server. With a two-way TLS connection, the server similarly identifies the client. TLS certificates for clients can be difficult to manage, and they generally aren't used with open API programs, though they are certainly used for some partners that may access privileged APIs, often in conjunction with other authentication mechanisms. For example, third-party payment processors may be using a bank's actual payment APIs, often have to have their servers present client certificates as part of their access. Like I already mentioned, API key is really used for its simplicity. We highly recommend OAuth. There are different grant types that can be utilized based on the level of trust and other requirements. A simple client credentials grant type where a system passes a client ID and a secret might work well for a trusted internal system. A third-party app that allows access to individual data, on the other hand, would need to use an authorization code flow, like I previously described, where the consumer authorizes the access. Finally, I'll mention that TLS certs used for two-way TLS make a lot of sense when you're using a service mesh that can manage all of that for you. One of the things in common with all of these methods is that they identify the calling client. OAuth tokens, however, can also identify not just the client, but the end user as well. So Dino, what situations do you see customers using these different mechanisms to secure their API access?
Well, the API key is a good basic building block. It's appropriate for use with an open API where you want to track who's calling the API. And also it can be used as a key identifier when doing signing or encryption. I'll talk more about that later. OAuth is pretty common. As you said, most API gateways will just support it. It's a really good idea. Two-way TLS, that's going to work for devices that are managed, point of sale terminals, devices that you control. Not so easy for consumer mobile devices or even partner systems.
Great. What about JSON Web Tokens, or JWTs? Can I use those for authorization and access?
Sure you can. JWT is just a special kind of token. OAuth bearer tokens are commonly opaque, a random string. No information is inherent within that string. JWT is different. It encodes actual claims. With an opaque token, only the authorization server that issued the token can resolve that token into a set of claims or entitlements. In contrast, any system can decode and verify the information in a signed JWT. So yes, JWT can be used as a bearer token to support authorization checks, and it may be more flexible and preferred in some cases. When to use each? As always, it depends. That's a larger conversation.
Spoken like a true architect, it depends. I've used that phrase many times myself. Now let's talk about securing your API messages themselves. I've worked with a customer that was dealing with consumer credit information. As you might imagine, they are passing around personally identifiable information that we would all prefer not be leaked. They use things like TLS and OAuth, of course, but in addition, they actually chose to pass some incoming payloads as a JWT using JSON web encryption. For those transactions, it gave them an extra layer of security. Even if someone got a valid OAuth token, they still needed to sign and encrypt the message itself. At a high level, there are really two key items when it comes to message security: signatures and encryption. Signatures provide message integrity and non-repudiation. Basically, a signature can contain a hash of the message and is often signed using a secret only the signer possesses, but can be verified by the receiver. In this way, we can verify that the message hasn't been altered and has actually been sent by the intended sender. Signatures don't provide any privacy for the message, though. For that, you need encryption. A combination of signatures and encryption can be used to protect sensitive data. HMAC is also used pretty widely by cloud providers. For example, in GCP, you can create a signed URL that allows distributed access to a storage bucket. Using encryption can be useful if you want to protect against things like a TLS vulnerability that would allow an attacker to view data in flight. It can also be useful to limit who is able to see data as it moves between systems or when stored on disk along the way. Generally speaking, this is only going to be used for your most sensitive data. This leads me to another question. Dino, do you have any recommendations for when folks should use these different message security mechanisms?
Sure, here are a few. First, keep it simple. Signing or encryption necessarily means more work for client developers and more complexity. Take care to apply it thoughtfully. Second, application layer signing or encryption helps protecting information across multiple hops in a chain. Third, select the signing approach that fits your team. So HMAC, RSA, whichever they're most comfortable with. And don't forget, JWT can be used to sign or encrypt payloads, not just ID tokens. In all of these cases, you're going to need to think about key management. Last, include a timestamp in the signed payload to protect against replays. JWT will help you with this. If you use HMAC or RSA, you will have to come up with your own convention.
Great, thanks, Dino. Securing conversations. Even with other security measures in place, sometimes attackers create accounts to try to mimic human users and gain access. Rarely, though, do these attacks follow the same patterns as normal use. Securing conversations generally makes use of modern technology, like machine learning, to consider usage patterns and potentially identify malicious traffic. This is where we start to get into things like bots. There are plenty of bots with bad intent. It can take advanced features to help identify and prevent this type of attack. There are a few things in the toolkit for securing conversations. One of the simplest can be rate limiting. It's unlikely, for example, that a human will be requesting a new token several times a second, or even more than once a minute. Anomaly detection has also seen an uptake with customers that I support. As we talked about, sometimes bad actors get through and that can change the error rate or the overall rate of traffic even. Anomaly detection applies machine learning models to understand what a normal traffic flow looks like and can alert when things like the error rate are outside of normal. This is all done without anyone actually configuring a specific alert. Security teams have come to rely on these alerts as a potential indicator that a bad actor is bypassing other security mechanisms. It also works great to alert to potential operational issues. And I've had more than one customer that has told me anomaly detection has helped them detect an error, alert the target service that was having the issue, and fix it all before they broke their SLO. You'll also see reCAPTCHA up here. Usually when I think of reCAPTCHA, I think of having to click on the annoying images or maybe type some difficult to read characters. Hey Dino, how could reCAPTCHA help with securing APIs?
Good question. So in the original version of reCAPTCHA, a web page presents the familiar "Are you a robot?" challenge. Google released version 3 of reCAPTCHA in 2018. In that version, it now relies on device and endpoint fingerprinting. There's no UI. That means both web pages and APIs can be protected by the same system. The client needs to connect to the reCAPTCHA server to get a token. That client uses that token in its request for an API token. The API server can then validate the reCAPTCHA token before granting service, and reCAPTCHA will issue an opinion about that client. Is it a robot or is it not? Using reCAPTCHA this way, reCAPTCHA acts as a gatekeeper or bouncer for your front door. It does mean introducing a new external dependency into your system, but you may want to accept that to get the additional level of security.
Perfect. Thank you. So when do you use what? API access token pretty much is always going to be in place. There are some exceptions for truly public info, but even then you may want to provide some level of access control. Signatures can be useful when you need to verify the integrity of the payload, or can even be used for distributed access, like the signed URL example. Encryption is useful when a message may be passed around between multiple systems in an asynchronous manner, or for the most sensitive data that you want to ensure that even if the wires are compromised, the content is still secure. This can also be used to ensure that messages are secure even when written to disk or if they're inadvertently written to logs. There are multiple areas where anomaly to bot detection might make sense, but we recommend that this is at least used to protect your login and token API. Ideally, you want to prevent the bad actors from ever getting a token in the first place. With that, let me turn it over to Dino, who will walk us through how we might be able to implement some of this inside of Apogee.
Information-driven companies will have tens or hundreds of services that they use to run their business. Some of them custom-built, maybe in Java, Golang, C#, Python, maybe running in a VM or in Kubernetes. Some of these services might be third-party, SaaS. There are many different implementation options. Apogee can help manage all of them. To do that, we rely on an Apogee proxy that intercedes between clients of the service and the service. This allows us to standardize on the access, message, and conversation security. For this demonstration, I have a single upstream service. It's implemented in Node. It uses Express, it's JavaScript, and all those details don't matter. The key detail is that it exposes an HTTP API. So let me show you what it looks like to invoke that. The service is running locally. I have my dev instance, and you can see it's an inventory and product management service. I can query it and get information about products. You can see Anvil, Birdseed, a bunch of other products. This is just the dev instance. I also have it running in Google App Engine. So let's try to invoke it there. There's a different URL. I'll send the same request. And you can see I'm getting a 401 unauthorized. The service is locked down. To enforce API management, we must ensure that the service is accessible only through the API gateway. We can do that with two-way TLS, firewall configuration with IP restrictions, or via some other mechanism. Apogee then acts as the enforcement point for clients. No client can reach the service except through the Apogee proxy. So let me show you a proxy that stands in front of this particular service. So here we see the target of the proxy, and this is the ingress endpoint for the API proxy. The proxy itself is just a pass-through. It receives the request and then proxies to the upstream. So let me turn on tracing, and then we'll flip back and we'll invoke not the Google App Engine endpoint, but the proxy endpoint in Apogee. You can see I'm sending that same request, and it's actually connecting to that App Engine instance, which, because it's Apogee, it's allowing it through. And you can see I've got a trace statement here. The request is received, and then it's proxied to the upstream target. So really nice, except Apogee is merely acting as a pass-through. We want the proxy to do more. So in order to illustrate that, let's stop the trace. We'll deploy version 12 of this proxy, which includes a verify access token policy. So now we're going to start doing OAuth enforcement in the proxy. Again, let me turn on a trace, and then I'm going to run that same request. And you should see Apogee saying, hey, unauthorized, you did not pass a token. So I'm not going to let you in. How can we get a token? Apogee also acts as a token dispensary. And I have another proxy for that. This is an Apogee OAuth proxy that generates tokens for the client credentials grant type. So I'm going to turn on trace for that. And now we'll request a token using client credentials. So that's a different API request. And you can see I'm sending that into Apogee, and yep, I've got an access token coming back. So that's really good. In the trace, you can see Apogee handled that request. It verified the client credentials and then generated a token, which is now good for 30 minutes. We now have the token. Let's invoke the service again. We'll switch back to the other proxy. We'll invoke the service again, passing that valid token. And now you can see Apogee is receiving the request. It includes the valid token, and I'm getting the product inventory information. So that's just what we want. What if I use an expired access token, something that's out of date? Also want to check that out. Want to make sure that access tokens get rejected when they are expired. And sure enough, Apogee is sending back, hey, that token is old, that's expired. It's doing exactly what we want it to do. Let's try an update. For this part of the demonstration, I have a payload. I want to send a post in. The payload looks like that. And I've configured the Apogee proxy in here to check the HMAC on that payload to prevent replays and to ensure greater message security, something we talked about a little bit earlier. So let's try to send that in. Send in a post with that update, with that payload as an update. And you can see Apogee is sending, hey, you need to send an HMAC for that request, which is, again, what we want. Let's try sending in that request with an invalid HMAC, the wrong HMAC for this payload. And you can see now Apogee is saying, well, you sent in an HMAC, but it was the wrong HMAC. That HMAC did not succeed. And here's the one where we didn't include an HMAC. Here's Apogee handling the request where we did send an HMAC, but it was the wrong one. This is the actual correct HMAC value that Apogee is expecting for this given payload. This is the value that I sent. So let's send the correct value. HMAC equals that value, and we'll send that same request again with the correct value. And now Apogee says, yep, that's good. That post, we've validated it. Apogee has validated it. The HMAC passed, and then it proxies to the upstream. The upstream system did not have to concern itself with tokens or HMACs. Apogee is doing all that work for you. So I didn't show it here, but remember, you'll want to include timestamps in your HMACs to prevent replays. In the prior examples, the client used a client credentials grant type, passing in the client ID and secret in the basic auth header in order to get a token. How about using a JWT as an alternative? Instead of passing a client ID and secret, the token endpoint in Apogee can require that the client signs the request for token using a key pair provisioned just for this client. And we can use as the signing mechanism JWT, that's standard. So how do we do that? First, we'll get a JWT. And I'll use this web page to generate a signed JWT using the private key that is associated to this client. Let me grab that JWT. And we'll set that as a shell variable. Now, I want to open up the JWT token dispensary. I'm going to turn on tracing there. And then we're going to send in a request for a token that passes that JWT. So here's a new request for a token passing in the JWT that I just set. Here's the grant type. It's a JWT bearer grant type. And now I've got an opaque access token in exchange for that signed assertion from the client. And that opaque token will work just like a token issued with client credentials grant type. So that's going to work just as expected. What if we use a JWT ID token to get as an exchange for a bearer token? So here, this is a page that allows me to sign in using Google Sign-In, which is just an OpenID Connect provider. And what that means is it will issue an ID token to an app that allows a person to sign in. So now I've got a JWT from Google. That's much bigger. It's got a lot more claims in it. You can see some of the claims here are decoded, the email address, the name, a URL for my picture, and so on. What if we use that to try to get a token? We can do that here with a new, different API proxy. So this one, rather than verifying a self-signed JWT from a client, it's going to verify that this is a token issued by Google Sign-In. You can use any OpenID Connect provider, Okta, Auth0, Azure, Google Sign-In. There are lots of other options, but any of them will have that same kind of approach with a JWKS endpoint. So let me try now obtaining a token with that JWT. We use a different endpoint. And sure enough, I'm getting now an access token in exchange for an ID token. So that's a really nice capability in Apogee. And you can see the flow in Apogee allowing verifying that request and issuing the token back. And again, that token will work just like any other token issued by Apogee. How about something a little different? What if we want Apogee to accept a JWT directly? So I've got a different API proxy endpoint for that. This one accepts a JWT and it just verifies that JWT. Again, this will be an ID token issued by Google. So we'll turn on tracing for that API proxy and invoke that. And you can see the API proxy is now accepting the JWT as an input token, and it's verifying that directly. So no opaque token, rather it's the full ID token issued by Google Sign-In. And as I said, you can use any OpenID Connect provider to allow that to happen. Last thing I want to show is, what about if we want to protect the token dispensary endpoint with reCAPTCHA? And I've got another API proxy here that does that. So again, this is a client credentials token dispensary in Apogee, but it protects the request with reCAPTCHA. And the way this works will become clear after I show you. The client page looks like this. So this is a bit of JavaScript that runs in a browser, and it uses the reCAPTCHA SDK from Google. Here, I use the client to obtain a token, a reCAPTCHA token, using the reCAPTCHA site key. Then, after the client gets the reCAPTCHA token, it can send in a request for an API token to Apogee, passing in the reCAPTCHA token as part of that request. Then Apogee in the proxy will verify that reCAPTCHA token. It does that here before issuing a client credentials grant type token. So let's see this all work. I've got the page running that, and I'll just click this button. It's obtaining the token from reCAPTCHA, sending that along with the client credentials grant into Apogee. And you can see that Apogee received that request and verified the token. Google replied with a response for that token, giving it a score of 0.9, which is sufficient. So the Apogee proxy issues the token as it did in all those other cases. And that's it. I hope that gives you a good idea of some of the things that you can do with Apogee for access security, message security, and conversation security.
Okay, those demonstrations, I hope, give you an idea of some of the possibilities Apogee offers for securing your APIs, focusing on securing access, securing the messages themselves, and monitoring and securing patterns of messages. So now I'll turn it back to Greg to bring it home for us.
Awesome. Thanks, Dino. Great demo. Today, we learned about different ways you can secure access, most commonly using tokens. You can secure your API messages with signatures and encryption. And finally, how advanced features such as anomaly detection and reCAPTCHA can help secure your conversations. You saw these different techniques can be applied differently to different APIs. Briefly see how you could actually implement some of this functionality quickly and easy using Apogee. I want to truly thank you for watching this session and offer to continue the conversation. I've set up some expert one-on-one sessions over the next couple of weeks. We will also be answering your questions in the question and answer section for this session. Thank you very much.